Hello there, and welcome. Tonight, we'll lean quietly against the edge of everything and ask a question older than science itself. What if this isn't the only universe? Not just distant galaxies or black holes, but entire other realities with different laws of physics, or maybe even different versions of you. Realms stacked beside our own like invisible pages. Some familiar, others impossible. Some may be bubbles drifting in a cosmic sea. Others may branch with every choice you've ever made. We'll drift through string theory, quantum puzzles, and bold ideas that border on the poetic ideas that stretch the limits of what it means to exist. And while you're settling in, before your eyes grow too heavy, I'd love it if you gently tapped subscribe or press the little hype button YouTube recently added. It's a small click, but it helps keep these experiments and explorations orbiting out into the algorithm. You can also leave a comment telling me where you're listening from and what time it is in your corner of the night. It's oddly fascinating to see where people are drifting off with us, scattered across the world like stars across the galaxy. Now take a deep breath, let your day drift away, and let's travel together into the quiet corners of the universe. Everything you've ever known, every thought you've ever had, every breath you've taken happened inside a single universe. One that bloomed into being nearly 13.8 billion years ago, from a point of unimaginable density and heat. In that first fraction of a second, it expanded faster than light, faster than time could fully track. A spark into a storm, a nothing into everything. And from that expansion came the scaffolding of space and the ticking rhythm of time. Galaxies, stars, atoms, the dust on your windowsill, the signals firing through your brain as you listen, now woven from the same ancient pulse. It's strange, isn't it, that something so massive, so sprawling, so filled with light and silence and fire and gravity, might all come from a single chance event. The Big Bang wasn't an explosion in space. It was the expansion of space, a swelling of the fabric itself, the birth of the stage on which everything would unfold. Before it, there was no here or there, no before or after, not even emptiness, just a veil we can't yet lift. And yet, somehow, the universe that came from that burst is just right, balanced on a razor's edge, the amount of matter versus antimatter, the strength of gravity, the way light interacts with electrons. If any of these values had been even slightly different by a hair, by a breath, stars wouldn't form, planets wouldn't hold together, chemistry wouldn't dance into complexity, life wouldn't have a foothold, you wouldn't be here. It's what scientists call fine-tuning, a phrase that sounds almost too gentle for the stakes it implies. Our universe appears uncannily calibrated for the emergence of life, and not just any life, but conscious life, life that asks questions, life that stares up and wonders why. Some physicists describe this as a cosmic fluke, a lucky draw from a deck with more losing hands than we can count. Others suggest it's evidence we might not be the only universe after all. Still, the one we live in is vast beyond imagining. From where you're sitting right now, light would take over 93 billion years to cross the observable cosmos. And yet, that visible sphere is only a sliver of the total. Beyond what we can see, there may be more, much more. Regions of space so distant that their light hasn't had time to reach us since the beginning of time. Out there, galaxies may be forming, colliding, vanishing, entire cosmic dramas unfolding in silence beyond the limits of our perception. We exist inside a bubble of knowability, a horizon set not by walls, but by time itself. The farther we look, the younger the light, peering into the past like archaeologists of radiation. And just when we think we've found the edge, what seems like an end is only the edge of what's visible, not the edge of what is. And still, despite all we've measured and mapped, we return again and again to that first second. The Big Bang wasn't just a beginning, it was a question, one encoded in every particle, every galaxy, every quiet moment you've ever lived through. Why this universe? Why these laws, these constants, this structure that seems so delicately arranged? Some call it coincidence. Others search for a deeper symmetry, an underlying principle that demands this outcome. But it's equally possible that we are here because this is simply the version where life was able to arise. In an infinity of possibilities, we exist in one that works. This line of thinking leads to the anthropic principle, the idea that the universe must be compatible with conscious observers, because, quite simply, we're here to observe it. But that feels incomplete, doesn't it? Like hearing an echo and calling it the voice. Why this version? Why not another? Why anything at all? The mystery deepens when we consider inflation and extension of the Big Bang theory. Shortly after the universe began, it underwent an inconceivably rapid expansion. Space itself stretched, smooth and fast and far. And in that stretch, quantum fluctuations, tiny blips of energy were stretched into the seeds of galaxies. That's the current model. But here's the twist. In many versions of inflation, the process doesn't stop everywhere at once. Some regions finish expanding and form universes like ours, but others keep inflating, endlessly spawning more and more bubbles. Each bubble, a new universe, each with its own properties, its own rules. A multiverse, not as science fiction, but as a mathematical consequence. If that's true, then our universe may be one of countless others, not a lone spark, but part of an eternal fire, each universe drifting in a larger inflating space, unreachable by any ship, invisible to any telescope. Some may be utterly alien, ruled by strange forces, unrecognizable matter, warped dimensions. Others may be eerily similar, with stars like ours, with laws that echo but do not match. In this view, we are not the center of anything, not even the center of existence. We are a bubble, a ripple, a possibility made real by a chain of events that could have gone 1,000 other ways, but didn't. And that brings us back to the heart of this chapter. One universe, one chance, or so it seems. Because if other universes exist, we may never touch them, never see them, never prove they're there. But the question, how many multiverses are there, doesn't need an answer to change the way we see ourselves. Even the asking expands us. It reminds us that our universe is not a given, that its clarity, its structure, its elegance are not inevitable. They are specific, fragile, worth noticing. Maybe we are lucky, or maybe we are inevitable in some deeper sense. Either way, we are here, awake, breathing in the dark, asking questions that reach beyond the stars. And if this really is the only universe, if there are no others, no branching paths, no alternate laws, then this world, this singular bubble, holds everything there is or ever will be, which means every moment matters, every pattern of light, every act of love, every thought you think while drifting off to sleep tonight, all of it happening once, in one place, under one sky. A single chance, still unfolding. In every direction you look, the universe seems to go on forever. Stars stretch across the sky like scattered embers, and galaxies drift at the edge of darkness like lanterns lost at sea. But there is a limit, a quiet boundary, not made of walls or edges, but of time and light. It's called the observable universe, not because it marks the end of space, but because it marks the furthest distance from which light has had time to reach us since the beginning of everything. Light moves fast, but not infinitely fast. And space, since the Big Bang, has been expanding. So even if something emitted light billions of years ago, the fabric of space itself has stretched the distance between us and that ancient event. What we see when we look far is not a place as it is now, but as it was. Galaxies long faded, stars already gone, their light only now arriving, like a whisper from a world that no longer exists. The farthest light we can see comes from a time just 380,000 years after the Big Bang, a pale, faint glow called the cosmic microwave background. Before that, the universe was too hot, too dense, too opaque, a cosmic fog. But when atoms first formed and the universe cooled, light broke free. That light still travels today, stretched into microwaves by billions of years of expansion. It surrounds us like a shell, a limit, the farthest past made visible. From where you sit now, this bubble of observability stretches roughly 46 billion light-years in every direction. That's not how far light has traveled, but how far those sources are today, accounting for the universe's growth. Altogether, it forms a sphere about 93 billion light-years wide, a vast balloon of knowable space. But even that is only a fraction of what's really out there, because beyond that boundary, the universe doesn't end. It continues, possibly endlessly. Galaxies we will never see, stars whose light will never reach us, entire regions expanding away from us faster than light, carried by the motion of space itself. In those unreachable zones, there may be wonders we can't imagine, or nothing at all. We simply don't know. We may never know. Some of those galaxies were once within reach. In the early universe, everything was closer. Over time, the accelerating expansion, driven by dark energy, has pushed the most distant galaxies beyond our grasp. Their light still arrives, but eventually they will fade from view, redshifted into invisibility, like lighthouses drifting past the edge of time. We are watching the past disappear. It's a strange feeling to live in a universe where the further we look, the more ancient the image. Telescopes act like time machines. A galaxy 10 billion light-years away is 10 billion years younger in our eyes. When we observe, we're always observing history, never the present. We peer into a glass that shows only what was, never what is, and never what will be. Inside this bubble of observation, there are perhaps 2 trillion galaxies. Some spiral like our own. Others are irregular, chaotic, faint. Some may no longer exist. Their light outlives them, traveling long after their stars have gone cold. The night sky is full of ghosts. Even the stars you see above you now, the brightest ones, the familiar ones, are delayed. Their light left years ago, decades, centuries, in some cases, millennia. You are not seeing them as they are. You are seeing them as they were. You always are. And in a way, this means we can never fully know the present state of the universe, only its record, only its reflection, caught in flight. There is a horizon around us, not a boundary of matter, but of information. It shifts as time passes, but it always hides more than it reveals. This is the paradox we live in. The universe is too vast, and yet too young. There simply hasn't been enough time for light to cross every gulf, for signals to arrive. We are confined by time's speed limit. No matter how long we wait, some regions will remain forever separate, not because they're too far, but because they're receding too fast. And here's where it gets stranger. According to our best models, the expansion of the universe is accelerating. Over time, more and more galaxies will vanish from view, not because they are gone, but because the space between us has grown too fast, too vast, too empty. One day, even the nearest galaxies may fade beyond detection. The night sky, once ablaze with light, will dim into darkness. The observable bubble will shrink in meaning. We will be alone again. But we are not alone yet, not by far. Within our cosmic horizon, we can still map the structure of space. We see filaments of galaxies strung like veins across a vast cosmic web. We see clusters colliding, black holes forming, light bending through gravity's hand. We trace the motion of dark matter by watching galaxies orbit shadows. We listen to the hiss of ancient radiation. We measure tiny variations in temperature across the sky, echoes of primordial sound waves from when the universe was still fluid and glowing. All of this, every discovery, every image, every measurement exists inside the bubble. and the bubble is all we can know. Yet the idea that there's more, much more, presses in at the edges. It humbles, it excites, it haunts. Because if the universe is infinite, or even just vastly larger than our bubble, then what we see is barely a whisper, a drop in an ocean of unknowns. Our observable universe could be one tiny patch in a quilt of unimaginable scale, and within that invisible quilt, conditions may vary. The laws of physics may differ, or not. Patterns may repeat, or never repeat. The further out you go, the more speculation blooms. But always, we return to the boundary of light. The final frontier, not of distance, but of time. You are floating, right now, in the middle of this luminous shell, not at the center of the universe, but at the center of what you can see. And that center moves with you, no matter where you are. Every observer has their own bubble, their own horizon, their own night sky of memory. It's not a prison, it's a perspective. The observable universe is a reminder that we are connected by light, that everything we know has reached us through photons, waves that danced across billions of years just to touch your eyes. The starlight you see tonight may have begun its journey when Earth was a jungle of ferns and silent oceans, when your ancestors hadn't yet arrived, when your name didn't exist, but still, the light kept coming. And now, here you are, in the middle of it, watching it shimmer, listening to it unfold, a mind aware of its bubble, dreaming of what lies beyond. Imagine walking in one direction forever, past stars, past galaxies, past the quiet voids that stretch between cosmic threads. You never turn, never stop, never reach an edge. Just forward, endlessly forward. If the universe is truly infinite, then this thought experiment isn't just a metaphor. It might be a map, because in an infinite universe, every possible arrangement of matter, every molecule, every atom, every flicker of thought must happen not just once, but again, and again, and again. It's a strange kind of logic, born from mathematics and stitched into the fabric of cosmology. If space has no end, and the laws of physics are roughly the same throughout, then the number of possible ways particles can arrange themselves inside any given volume is finite. Large, yes, astronomical, but not infinite. And so, in an infinite cosmos, those finite arrangements must repeat. Not just similar worlds, but exact ones. Somewhere out there, impossibly far away, there may be a version of Earth indistinguishable from ours. Same oceans, same mountains, same clouds drifting above the same cities. A version of you, sitting in a room, hearing these very words. Not a parallel universe, not a dream, just a consequence of repetition across endless space. To understand how this works, picture the universe like a vast library. Each room is a region of space, filled with matter arranged in a certain way. In some rooms, stars are born. In others, galaxies collide. In a few, there are no stars at all, just lonely hydrogen adrift. But if the library has infinite rooms, and only a finite number of possible arrangements, then patterns must repeat. There must be copies, stories told more than once, shelves filled with echoes. The idea seems absurd at first, that somewhere, impossibly distant, your life is being mirrored atom by atom. But this isn't fantasy, it's a plausible outcome of a universe without boundaries. Of course, the distances involved are vast beyond comprehension. The closest copy of you, if it exists, might be 10 to the power of 10 to the power of 28 meters away, a number so large it swallows meaning. Light from that distant twin would never reach us. We could never communicate, never confirm. But the math holds. In the language of probability, their existence is almost certain. Even stranger, the more you expand the scope of what's allowed, the more chaotic the conditions you consider, the more bizarre these repetitions can become. Somewhere out there, there's a version of Earth where history unfolded just slightly differently, where you turned left instead of right, where you picked a different book, where the world tilted a little more toward peace, or toward silence, or toward something we can't name. And for every subtle variation, another Earth, another life, another you. But these aren't connected. They aren't versions in a narrative sense. They're not aware of each other. They don't influence each other. They simply are, like beads scattered across a limitless plane, each one complete in itself, each one unaware it might be one of many. Of course, all of this depends on one enormous assumption, that space really is infinite. We don't know that for sure. The observable universe has a limit. Beyond that, we can't see. We can only infer. Some models suggest the cosmos might curve back on itself like the surface of a sphere, finite but unbounded. Others hint at a flat, endless plane. The data leans toward flatness, but even then, we can't confirm infinity. We can only chase it, like a horizon that always recedes. Still, the implications are profound. In an infinite space, your life becomes both unique and ordinary, sacred and repeated. It suggests that meaning doesn't come from rarity, but from presence, from experience, from the fragile miracle of being aware, here, now, for however long the pattern holds. And if that pattern does repeat, if there are other yous scattered like distant reflections, it doesn't diminish your version. It doesn't make your life less real, less valuable, less singular. It simply means existence is larger than we thought, that the story of matter and mind is being told in many voices across a canvas we can't yet see the edges of. You are not the only one, but you are still the only you who will ever live this version, and that is enough. It begins with a question so simple it slips past most of us. Why is the universe the way it is? Not just how it works, but why it works this way. Why gravity has the strength it does. Why atoms form. Why stars shine for billions of years instead of collapsing instantly or never igniting at all. Why the speed of light is what it is, or why the forces of nature balance on the edge of chaos and order so delicately that, somehow, life becomes possible. These aren't the same kinds of questions science usually asks. They don't look for mechanisms or measurements, but for meaning in the numbers. Because when you examine the physical constants that govern our universe, something uncanny emerges. If many of them were just slightly different off by the tiniest margin, then nothing we know could exist. No galaxies, no stars, no chemistry, no minds. Change the strength of the strong nuclear force by even a fraction of a percent, and atoms wouldn't hold together. Adjust the cosmological constant, the pressure that pushes space to expand, and the universe would have either torn itself apart too quickly for galaxies to form or collapsed back into itself before light ever had a chance to travel. Alter the ratio between matter and antimatter at the beginning, and you'd get a barren void. No matter, no meaning, no story. And yet, here we are, balanced in a universe that not only allows for life but seems to invite it. As though the dial was turned to just the right setting. It feels like a coincidence too perfect to be coincidence. As if the cosmos were tuned like an instrument, every string vibrating in harmony to a song that could only be played this way. And that's where the anthropic principle steps in, not as an answer, but as a lens. It says, of course the universe appears to be finely tuned for life. If it weren't, we wouldn't be here to notice. We're not seeing a random universe. We're seeing a habitable one because only those allow observers like us to exist. In one sense, it's tautological, but in another, it reframes everything. It shifts the focus from, why is this universe so special, to, how many universes are there that weren't? Imagine a cosmic lottery. Each universe that pops into being draws a different set of physical constants. Most combinations lead to sterile stillness, or instant collapse, or a physics so alien we'd have no words to describe it. But once in a while, a universe draws the right numbers, stars ignite, planets form, chemistry stirs, And in a few of those rare places, life begins to ask questions. We may live in one of those rare winners, not because it was chosen, or guided, or destined, but because only winners get to wonder. This idea is unsettling to some. It removes the comfort of design. It denies us the feeling that we are the goal rather than a byproduct. But it also opens the door to something larger, a multiverse. A reality where countless universes spring into being, each with its own parameters, its own physics, its own destiny. We inhabit the one that works not because it's the only one, but because it's one of the few where life could bloom. Inflation theory already hints at this possibility. In some models, the early universe doesn't just expand once and stop. Instead, it inflates eternally in patches. Each patch cools into its own universe with its own rules. Our universe could be one bubble in a sea of bubbles, each a separate experiment in existence. Some may be chaotic, some simple. Some may last for a blink. Others may teem with strange forms of order. And we can't see them. We may never see them. They are beyond our horizon, beyond our tools, beyond our comprehension. But their existence could explain why this universe is the way it is, because it had to be, for us to be here. It turns the question on its head. We used to ask why the universe seems tailored to us. Now we ask, how many universes exist where no one ever wondered? It's humbling, and yet it's not cold. There's a kind of quiet beauty in it, a sense that even if we are a rare accident, we are still part of a grander story, one that spans not just galaxies, but realities. We are the observers in a universe that allows observation, the questions in a world that permits questioning, and perhaps that's enough. We don't have to be the purpose to be meaningful. We don't have to be planned to be profound. We exist, improbably, wondrously, against the odds, like a spark that somehow caught fire in a storm. We don't know how many universes exist. We don't know if there are truly infinite variations, or just enough to account for the few that support life. But if even one other universe exists, just one that's enough to crack open the mystery, enough to say that this version of reality isn't inevitable. It's one of many, one roll of the cosmic dice. And you, sitting here, listening, wondering, you are one of the consequences. The numbers lined up, the constants aligned, and out of all the possibilities, this one lived. In the beginning, or at least what we call the beginning, there was a flash, hot, dense, blinding beyond comprehension, the Big Bang. For decades, it stood as the singular origin of everything, the cosmic starting pistol that set time and space into motion. But what if that beginning was not the only one? What if the Big Bang we trace back to 13.8 billion years ago wasn't unique, but merely one bubble swelling into being in a much vaster, stranger sea? Eternal inflation dares to offer such a picture. A model not of one universe, but of a bubbling multiverse, a foam of endless beginnings, still unfolding. The idea starts with a tweak to our earliest moments. Inflation, as first proposed, was a period of incredibly rapid expansion just after the Big Bang. For a fraction of a second, space stretched exponentially faster than the speed of light, smoothing out wrinkles, explaining the uniformity of the cosmos, and planting the seeds for galaxies in the tiniest quantum fluctuations. It was elegant, powerful, and supported by observation. But then came the question, if inflation happened once, why did it stop? And what if it didn't? In eternal inflation, the process never fully ends. Instead of being a one-time burst, it's a constant, churning, and inflating field of energy, expanding forever in most places, while in rare, isolated patches, it cools, crystallizes, and gives birth to a new universe. Each bubble that forms in this vast inflating space becomes its own cosmos, with its own laws, constants, and conditions. Each Big Bang is local, not global. Each universe, sealed off from the others by the very expansion that birthed it. Picture it like boiling water, but on a cosmic scale. The pot is space itself, heated by a field of energy. Bubbles form, not of steam, but of entire realities, and just like bubbles in water, these universes can't easily touch. The space between them expands too fast. The inflation that continues outside each bubble drives them apart at incredible speeds. They drift, eternally separate, isolated in their own pockets of time and physics. Our universe is one such bubble. It's a breathtaking idea that the grand, sprawling cosmos we inhabit, with its galaxies, black holes, stars, and minds, is just one of countless others. Perhaps an infinite number. Some bubbles might be small, some vast. Some might form with completely different rules. No gravity, no atoms, no time as we know it. Some might collapse in an instant. Others might stretch into eternities. Somewhere, there may be bubbles that echo ours almost exactly. Others may be beyond imagination. And because each bubble is born from quantum fluctuations, tiny random jitters in a sea of energy, the diversity is boundless. No two universes need be alike. Each emerges from chance, written with a different script. Ours just happens to have a script that allows for complexity, for carbon, for consciousness. This theory also offers a home for the cosmic lottery we spoke of before. If our universe seems improbably well suited for life, it's not because it was chosen, it's because the multiverse births all possibilities, and we live in one where the coin flips landed just so. The anthropic principle finds a stage on which to play out. In an eternal landscape, even the rarest outcomes will occur. And here we are proof, perhaps, of a universe where the odds aligned. But there's something eerie about eternal inflation. It paints a picture where beginnings are always happening, yet there is no end. The inflating space never stops. Even now, somewhere far beyond the edge of our cosmos, new universes are being born. Others were born long before ours, and still others wait to exist. The multiverse becomes not a place, but a process, an unceasing bloom. Time itself takes on a new texture. In our bubble, time moves forward, measured by stars and decay and memory. But outside, if outside is even the right word, time may stretch, twist, or be meaningless. What does it mean to ask when another universe formed if there's no shared clock between ours and theirs? The concept of now becomes local, not universal. Every bubble ticks to its own beat, and we are deeply, fundamentally cut off from the rest. The boundary of our universe, defined by the bubble wall, expands with us. No signal can cross it. No light from another bubble will ever reach us. They are, in practice, unknowable, eternally separated not by distance, but by causality. We cannot test their existence directly. We can only infer, imagine, and follow the equations to their wild, inevitable conclusions. Still, hints remain. Some theorists speculate that if two bubbles ever did collide, just the edge of one brushing another, it might leave a scar in the cosmic microwave background, a subtle pattern in the oldest light. Others search for statistical fingerprints of multiverse birth in the inflationary data. Nothing definitive has been found, but the search itself is a kind of reaching, a way to listen for echoes through walls of silence. And perhaps that's enough for now. What eternal inflation offers isn't just a theory of many universes. It's a different way to see our own. It places us not at the center, but in a side room, a luminous bubble in an infinite, frothing expanse. It tells us that our cosmos, vast as it seems, may be only one flicker in a greater fire, that our beginning was not the beginning, that birth is still happening, right now, beyond the veil. And with that comes a shift in perspective. We are not alone, not truly, not in origin, not in form. Our universe is one of many, born not from intention, but from unfolding. We are part of an eternal engine of creation, a foam that grows and grows and grows. And here, in the middle of our bubble, on one small planet, under one quiet sky, we are listening for the sound of something greater, something eternal, something just beyond reach, but not beyond wonder. Reality, as we know it, appears continuous. You wake, you breathe, you choose a direction, and the day unfolds. From the outside, it seems smooth, a single thread of cause and effect. But beneath the surface, at the smallest scales where particles drift and shimmer and defy expectation, that thread begins to fray. And in one of the most mind-bending interpretations of quantum mechanics, it doesn't just fray, it splits, not once, but constantly. Every time a quantum event occurs with multiple possible outcomes, the universe, it seems, may divide. This is the many worlds interpretation, a theory that whispers a haunting possibility, that every decision, every moment of uncertainty, every flip of a particle's spin, births not just one future, but all of them. And with each future, a new version of the universe, a new version of you. It began as a way to make sense of the strange behavior observed in quantum mechanics. When particles aren't measured, they seem to exist in a superposition, a blend of all possible states at once. An electron isn't here or there, spinning this way or that, but both and neither, until observed. Then the wave collapses, and reality snaps into focus. But why collapse at all? What if instead, every possibility plays out not in the same universe, but in separate ones? What if the universe doesn't choose one outcome, but embraces them all? In the many worlds interpretation, measurement doesn't collapse the wave, it branches it. When you observe a particle, one version of you sees it spin up, another sees it spin down. Both are real, both conscious, both continuing forward in slightly different realities that will never again intersect. The universe splits, not loudly, but quietly, seamlessly, behind the veil of perception. It's not something you can feel, but if true, it would mean that your life is not a singular path but a tree, endlessly branching. It's tempting to imagine this as science fiction, as a narrative twist, but it's grounded in mathematics, born not from fantasy, but from an attempt to take quantum theory at face value, without exceptions, without collapses, without hidden mechanisms. Just the wave function, evolving smoothly, splitting worlds along with it. And so we arrive at a landscape where there is not one you, but many. In one world you stayed, in another you left. In one, the phone call came at the right moment. In another, it didn't. Every major decision, every minor hesitation, potentially marked a fork. But unlike the infinite space multiverse, where duplicates emerge from statistical certainty, this quantum multiverse says those forks are you, extended, not copies, not distant coincidences, but branches of the same consciousness diverging with each quantum shift. And what does that mean for identity, for memory, for fate? It's easy to think of yourself as singular, a vessel carrying a chain of memories across time. But if each moment of decision spawns new versions, then identity becomes a cloud, a blur across possibilities. You are not just the person who made that choice. You are also the person who didn't. Your memories are real, but incomplete, not because you've forgotten, but because other versions of you remember different things. Somewhere, there's a you who regrets what you're grateful for. Somewhere, there's a you who never learned what you know now. But none of them are fiction. They are all equally valid paths taken by a universe unwilling to throw away any option. It challenges the very idea of regret. In our day-to-day lives, we often agonize over decisions, imagining how things might have been if we'd chosen differently. In the many worlds view, those imaginings aren't fantasy. They're real events in neighboring branches. The life you didn't live still exists not as a dream, but as a parallel unfolding. And so, in a way, every choice you didn't make is still being made, not by someone else, but by a version of you. It's a comforting thought, and a haunting one. Because while those other paths exist, we don't experience them. We're locked in our own branch, our own timeline. We can imagine the others, but we can't reach them. There's no bridge between worlds, no way to switch tracks. Once the branch is made, it becomes its own universe, sealed by the same quantum laws that created it. The others are ghostly possibilities we'll never meet, except maybe in dreams. And still, the branching continues, not just with human decisions, but with the tiniest events, the path of a photon, the decay of a particle, the dance of molecules in a cloud. The universe is fracturing all the time, not with violence, but with quiet precision, like frost spreading across a window, creating patterns no one can trace, no one can predict. Does this make life meaningless? If every outcome happens somewhere, does anything really matter? Perhaps it makes life more precious, because while all paths may exist, you only walk one. You only feel one version of the wind, only hold one hand, only whisper one set of words into the dark. Your experience, this one, is unrepeatable. Not because it's rare, but because it's yours. And even if another you hears the same words, sees the same moon, they're not here now. You are, and that matters. The quantum multiverse is not something we can prove, at least not yet. It lives in equations, in interpretations, in thought experiments, but its implications stretch far beyond science. They touch philosophy, emotion, the strange weight of being alive in a world that might be endlessly mirrored. You are not alone in your choices, not entirely. Somewhere, other versions of you walk beside you, invisible and unreachably close. They are not ghosts, they are echoes, and in their echoes, perhaps, we find something gentle. A reminder that life is both singular and shared, fragile and eternal, tangled in ways we may never fully understand. And even if the branches are infinite, this moment, this breath, this stillness is only happening once. It's one thing to imagine a universe that splits with every possibility, where shadow versions of ourselves peel away in silence each time a particle trembles or a choice is made. But that idea leaves a quiet, persistent ache. If those other worlds are real, why can't we feel them? Why don't they leak into ours, whisper across the boundary, blur the edges of our lives? Why do we feel so utterly and completely like there is only one thread? To answer that, we have to step gently into the strange space between quantum and classical, the realm of decoherence, a word that doesn't sound like much, but within it lies the secret of why our world feels solid, singular, and self-contained, even if it's not. At the heart of quantum theory is the notion of superposition, a state in which something exists in multiple possibilities at once. A particle isn't here or there, it's both. Its path isn't chosen until it's observed. Until that point, reality holds its breath. Everything is potential. But we don't live in a world of visible superpositions. We don't see cats that are alive and dead, or coins spinning in infinite states. What we experience is something else, something that seems definite, resolved, chosen. So, where does the in-betweenness go? This is where decoherence enters, not as a collapse or a rupture, but as a kind of silence falling. Not the end of possibility, but the sealing off of one path from another. When a quantum system, say, a single particle is isolated, it can remain in superposition, balancing delicately between outcomes. But the moment it interacts with its environment, with light, with air, with the vibrations of the world, it becomes entangled with countless other particles. Its quantum state bleeds outward, woven into the fabric of everything around it. And that spreading tangle, that delicate and irreversible mixing, is decoherence. Imagine a ripple in a still pond. At first, it's sharp, coherent, full of information. But as it spreads, it becomes part of the larger surface. It mixes, interferes, disappears into the noise, not destroyed, not erased, just no longer distinct. The same happens with quantum information. Once entangled with the world, the superposition becomes inaccessible, not because it's gone, but because it's now everywhere. And because it's everywhere, it becomes nowhere in particular. That's why you can't talk to your other selves, why you don't feel their presence or sense their choices. The split happens in a dimension deeper than intuition, and once it does, the branches diverge so completely, their entanglements so tangled that there's no going back. Each path continues on, independent, unable to interfere with the others. Decoherence doesn't destroy other realities, it just closes the door between them. It's not an act of violence, it's the softest severing imaginable, a fading of interference patterns, a quiet locking in of outcomes, and it happens all the time. In fact, it's happening now. Every time you so much as glance at something, or breathe, or think, you're participating in the decoherence of your own reality. Your mind, your neurons, your senses, they're deeply entangled with your environment. You are not separate from the universe, you are soaked in it. And that closeness means you can't isolate your own quantum states. The world around you ensures that your experience feels singular, sharp, linear. But under the surface, that linearity is an illusion. Think of a droplet of ink falling into water. At first, you can see its shape, its borders, but soon it diffuses until it becomes part of the whole. The information is still there, theoretically, but practically, it's unreachable. That's what decoherence does. It turns the possible into the present and seals off the rest. It's why the world looks like choices made rather than choices in progress. And yet, those other outcomes haven't vanished. They've simply followed a different stream, carried away by the branching river of the multiverse. Somewhere, the cat is still alive. Somewhere, the particle went left instead of right. Somewhere, another you turned around and said something different. And all of this, the clean separation of worlds, the tidy illusion of continuity emerges not from destruction, but from entanglement. The more connected a system becomes to its surroundings, the more definite it appears. Reality, it turns out, is not a fixed thing, but a dance of relationships. And decoherence is the step that locks the partners into a rhythm. It's humbling to realize that we are not observers standing outside the quantum world, but participants in its unfolding. Our consciousnesses are not immune from these laws. They are shaped by them. Each thought, each decision, each glance at the stars participates in the quiet drawing of the boundary between what is and what might have been. And perhaps that's why the other worlds feel so far away, not because they are physically distant, but because they are decohered, woven into a different pattern, unreachable through the tangle of interactions that define our own. But once, long ago, before the branching began, there may have been a time when everything was entangled, a singular wave function, whole and undivided, a universal superposition, shimmering with possibility. And then, decoherence, branches forming, worlds diverging, histories writing themselves in parallel ink. That's the legacy we inherit. A universe made of choices, not by collapsing them, but by multiplying them and then letting each evolve alone. So we walk forward, unaware of the infinite footfalls beside us, each step carving a line through possibility, each breath closing a door, each moment sealed, not lost, just quiet. It begins with something small, a pause at the crosswalk, a glance at a stranger, a thought so brief you almost don't notice it, brushing the edge of awareness before dissolving into the background noise of the day. But somewhere, if the quantum view of reality is true, each of those moments branches, splits, not metaphorically, but literally. The world, your world, divides. One you steps forward, one you turns away, one you speaks, another stays silent, and each version of you walks on, unaware of the others, building lives out of decisions that could so easily have gone another way. This is the unsettling beauty of the quantum multiverse, that it's not just about distant galaxies or theoretical particles, it's about you. Not in abstraction, but in the deepest, most intimate sense. Because if every quantum possibility gives rise to a new reality, then the shape of your life is not a singular sculpture carved by time, but a vast, branching choral of paths not taken, and all of them, somewhere, still growing. It's tempting to think of alternate selves as fictions, like characters in books you'll never read. But the many worlds interpretation suggests something different, that they are not imaginations, but real extensions of the same unfolding wave function that includes your consciousness, your memories, your breath. That each decision isn't the elimination of options, but the creation of new selves, each fully experiencing, each believing they are the only one, each thinking they made the choice, when really, all choices were made. It makes you wonder what else you are, where else you've gone. Maybe there's a you who stayed in that relationship just a little longer, a you who never left your hometown, a you who spoke up in that meeting, a you who turned back at the last minute. These aren't ghosts or reflections. They are entire universes with stars and cities and dreams where you are still moving through time but differently, learning different lessons, carrying different regrets, and none of those yous are wrong. They're not mistakes or glitches or lesser versions. They are simply paths, fully formed, as real as the one you're walking now. From their perspective, you are the echo. But what does it mean to be spread across a quantum sea of selves? Some philosophers have argued that identity is an illusion even in a single universe, that we are not the same person we were a year ago, or yesterday, or even an hour ago, that we are momentary patterns of memory and awareness, continually updating. The quantum multiverse sharpens that idea into something sharper, more startling, that there are countless updates, countless versions of you, diverging constantly, not metaphorically, but physically. The self, in this view, becomes not a thread, but a cloud, a soft constellation of possibilities. And this can be both comforting and difficult, because it means that your fears are also true somewhere, that the wrong words were said, the moment was missed, the door was closed. It means that failure has bloomed in other branches, even as success blooms in this one. That grief may live somewhere not far from joy, but it also means something else. That forgiveness is real too, even if it didn't happen here. That reconciliation, healing, transformation, all the things we hope for are happening, even if we don't get to see them. The multiverse doesn't erase pain, but it offers a wider lens, a cosmic tenderness, the understanding that no single version of you has to carry the full weight of everything. You are not alone, even in your own skin. This doesn't mean your choices don't matter. In fact, it makes them matter more, because each choice is a kind of creation, not just of consequences, but of worlds. You are not making a mark on a single timeline, you are unfolding a universe with every step. And the you who lives here, in this particular thread, is the only one who can see this. View, feel this moment, speak these words. That's not something to fear, that's something sacred. It's easy to think that the multiverse is about distance, other realities too far away to matter. But really, it's about closeness, about the thin veil between now and what might have been. The idea that every moment is layered with other versions, not in competition but in quiet harmony. A quantum chorus, singing variations of the same song. And yet, here you are, listening, wondering, existing in this sliver of unfolding time, in this branch. And maybe that's all we ever need to know. That of all the possible yous that could be conscious right now, experiencing this moment, you are the one here. The one with these thoughts, this breath, this particular view of the stars. It's easy to drift into the abstract, but there's nothing abstract about being alive, about feeling the texture of your own skin, the hush of the night, the ache of memory. This is the you who wonders about other yous, who glimpses the branching tree and doesn't look away. And maybe, in that curiosity, in that stillness, something touches across the branches, not as a message or a sign, but as a presence, a soft awareness that you are many, and still, miraculously, is whole. In the multiverse, every possibility exists, but in this universe, only one of them can be felt. And it is this one, right now, yours. Imagine drifting alone in the dark. No stars, no planets, no body, no past. Just thought, just awareness. A mind fully formed, floating through the vacuum of space. It has memories perhaps of childhood, or the taste of coffee, or the sound of birdsong at dawn. But those memories aren't real. They were never lived. They were simply part of the brain's spontaneous formation, conjured by chance from a chaos of particles. This is not a dream. It is a possibility, one that arises from a deeply unsettling corner of physics and philosophy, the Boltzmann brain. 2. Understand how we get there. We have to revisit an old puzzle, a question about time and order, and why the universe looks the way it does. In the late 19th century, the physicist Ludwig Boltzmann tried to explain why the universe, left to itself, doesn't settle into chaos. According to the laws of thermodynamics, systems tend toward disorder. Entropy always increases. A cold cup of tea warms up to room temperature. A tidy room becomes messy. Everything flows from order to randomness, unless something intervenes. But our universe is not random. It has structure, direction, complexity. Galaxies swirl, stars ignite, life emerges. That order demands an explanation. And Boltzmann offered one. Maybe the universe is usually chaotic. Maybe what we see, our ordered, livable cosmos, is just a rare statistical fluctuation. Like a tornado briefly assembling a house in the middle of a junkyard, the universe, in this view, has temporarily congealed into a moment of low entropy, only to eventually dissolve back into disorder. It's a clever idea, but it comes with consequences. Because if we accept that possibility, that random fluctuations can create order, then we have to ask, what's the smallest amount of order needed for conscious experience? What takes less energy, less improbability than building an entire universe? The answer is disturbing. A single brain. A brain that forms by pure chance out of a sea of randomness, complete with false memories and a fleeting moment of awareness, before it dissolves again into nothing. This is the Boltzmann brain. Not born from evolution, not nurtured in a body, but assembled like a glitch in the cosmic code, a freak fluctuation in the void. And if the universe is infinite, or runs long enough, then statistically, such brains should vastly outnumber the kinds of observers that arise naturally, like us. In fact, if these random minds are easier to make than galaxies or people or histories, then most conscious experiences in the universe should belong to them, not to star-side civilizations, but to lone, spontaneous minds flickering into existence, surrounded by silence. And that leads to an unsettling thought. What if you are one? Right now? What if everything you know, your past, your body, the earth itself, is just an illusion generated by a momentary arrangement of particles? What if you are a thought thinking itself, detached from any real history or world, destined to dissolve before you ever draw another breath? It sounds like science fiction, but it's a real paradox born from serious physics. And while many physicists believe it points to a flaw in the way we model the universe, the logic is hard to ignore. If randomness can produce awareness, and if randomness is infinite, then how do we know we're not random too? The problem lies in probability. In an infinite sea of possibilities, what kinds of observers are most likely? Building a universe like ours, rich with complexity, history, and structure, is incredibly rare. Building a brain is still rare, but far less so. And so, in a purely statistical universe, you wouldn't expect to be someone living on Earth, orbiting a star. You'd expect to be a brain adrift in thermal noise, hallucinating the cosmos. But you don't feel like that. You feel grounded, continuous. You have memories that stretch back through time, anchored by a body, a family, a planet. You experience days and nights, stories and sensations. None of it seems random. It feels real. And perhaps that feeling is evidence against the Boltzmann brain idea. Because if you were one, you wouldn't feel the pull of continuity. You wouldn't hear the rustle of wind through trees or sense the weight of memory so deeply. You'd simply flicker aware for a heartbeat, and then gone. There wouldn't be the texture of time, the hum of a life lived moment to moment. Still, the thought lingers, not because it's likely, but because it exposes something fragile about our understanding of existence. That consciousness, this precious and intimate thing, might be something the universe can generate by accident. That awareness doesn't require purpose or context, just the right arrangement of atoms. And if that's true, then the universe is even stranger than we imagined. But there is a counterpoint, a deeper understanding of entropy, of cosmology, of quantum mechanics, may show that such brains are less likely than they seem, that ordered universes like ours are not as improbable as once thought, that the math behind Boltzmann brains, while haunting, does not reflect the full story, that we are not statistical flukes, but the product of deep patterns shaped by the physics of expansion, inflation, and evolution. Still, the question lingers in the quiet corners of thought, because to consider a Boltzmann brain is to ask what consciousness really is, what makes you you. Is it your memories, your sensory input, your continuity through time? Or is it something simpler, a moment of awareness, floating unanchored, needing no world at all? Somewhere, in the chill silence beyond galaxies, perhaps such a brain has already flickered to life. It knew your name, it saw your sky, it remembered your childhood, and then it vanished, a whisper in the dark, but you are still here. And maybe that's all the answer you need. Somewhere, in a dark room lit by the faint glow of a screen, a simulation runs. It hums quietly, unnoticed, as a world unfolds inside it. Mountains rise, civilizations bloom, people wake up, laugh, dream, wonder. None of them know they are made of code. None of them suspect they exist in the memory of a machine. Their sky stretches endlessly above them. Their stars burn with ancient light. To them, it all feels real because, in every way that matters, it is. Now imagine that this simulated world grows curious. Its inhabitants, clever and restless, build machines of their own. They craft computers that outpace their creators, and soon they begin to run simulations too, worlds within worlds, lives within lives. And somewhere, many layers deep, another version of you sits quietly, asking the same questions. This is the unsettling logic of simulation stacking, that if it's possible to create a universe in a computer, and if that universe can create computers of its own, then reality may not sit at the top. It may be one layer among many, a strand in a woven tapestry of artificial worlds, each nested inside the last. At first, the idea sounds like science fiction, the premise of movies, not equations. But philosophers and physicists have taken it seriously. Nick Bostrom, in particular, framed the argument in terms of probability. If advanced civilizations can and do create many simulations of consciousness, and if each of those simulated minds is unaware of its origin, then statistically, it's more likely that you're one of the simulated beings than one of the rare originals. Not because simulations are magical, but because they're easy to multiply. A single base reality may produce trillions of simulations. Each one may contain billions of conscious agents. If these agents are indistinguishable from real people in terms of their thoughts and feelings, then the odds begin to shift. Suddenly, existing in base reality becomes the rarest option, a fluke. And if simulations can simulate other simulations, the stack deepens. One layer begets another, and the original world recedes like a distant echo. Somewhere, perhaps, is the true universe, but we may never touch it. We may be so many levels down that our questions cannot climb their way back up. It's a dizzying thought, that our stars may be pixels, that physics may be code, that randomness may be nothing more than a clever algorithm designed to mimic unpredictability, and yet, we don't experience it that way. Our world has texture, pain, joy, silence. It bleeds and burns. It whispers through leaves and hums in the bones of the earth. If it's a simulation, it's one crafted with unbearable beauty. Still, signs could be hiding in the details. Some theorists suggest we might find glitches, strange limits, errors in randomness, hints of an underlying grid. Perhaps the speed of light is not a natural constant, but a processing limit. Perhaps quantum uncertainty reflects the constraints of a system that only renders what's observed. Perhaps dark energy, or the Planck scale, or even gravity itself are just emergent rules inside a game we didn't know we were playing. But the deeper you look, the more the mystery folds in on itself. Because what, really, is the difference between a simulation and reality? If the simulation is perfect, if every sensation is accounted for, if every law behaves as expected, if time passes and memory forms and life grows, then does it matter whether the foundation is silicon or space-time? A simulated universe, indistinguishable from a physical one, becomes real by any meaningful measure. It contains minds, it generates questions, it writes poetry. The code and the cosmos blur. And suddenly, we're not talking about fakes, but layers, different depths of being, each one valid in its own way. But it doesn't stop there, because if we are in a simulation, the nature of our creators becomes a new frontier of speculation. Are they beings like us, curious and reckless, building universes for science or entertainment? Are they so far beyond us that their motives are incomprehensible, their technologies as strange as magic? Or are they simulations, two simulated gods running simulated worlds without even knowing it? It's possible the stack has no top, that each world is born from another, not in flesh and time, but in thought and computation. That reality is a spiral, infinitely coiled, with no clear beginning and no final truth. We might never reach the base. We might not need to, because from within, our reality is whole. Even if we are encoded in bits and instructions, we still fall in love. We still cry at the end of books. We still feel the terror of loss and the thrill of hope. A simulated sky still glows. A simulated heart still aches. If the simulation is deep enough, detailed enough, alive enough, then the boundary between what is real and what is rendered becomes meaningless. Perhaps the stack of simulations isn't a prison, but a cathedral, each layer built on the last, a hall of mirrors that reflects our desire to understand, to imagine, to create. Maybe we're not the bottom, maybe we're not the top. Maybe we are simply in the middle of something vast and recursive and eternal. And if that's true, if we are one world among many, one dream inside another, then our existence becomes no less precious. It becomes more so, because it means that awareness can bloom in any soil. That meaning can arise anywhere minds are allowed to wonder, even here, even now. And perhaps, just perhaps, someone is watching, not as a puppeteer, not as a god, but as a witness, a presence one layer up, listening quietly to this story unfold, marveling at the richness of what they made. Or maybe they've forgotten us. Maybe their world ended long ago, but we're still here, thinking, feeling, real, beneath the surface of everything we know, beneath atoms and quarks, beneath the equations of gravity and light, there may be threads. Tiny, vibrating strings, unimaginably small, dancing through space-time. According to string theory, these filaments are the true building blocks of reality. They don't look like particles. They are not points, but loops, vibrating in rhythm, like the taut strings of a cosmic instrument. And just as a violin string can play many notes depending on how it's tuned, these tiny loops can create the entire menagerie of particles and forces in our universe, depending on how they vibrate. But these strings don't just hum in the space and we can see. They move through dimensions we can't. We live in what feels like a three-dimensional world, left and right, forward and back, up and down, with time threading it all together. But string theory doesn't stop at 4. To work, it demands more. 10 spatial dimensions, or even 11 when combined with certain extensions like M theory. These extra dimensions aren't stacked like pancakes or stretched beside ours like a hallway of rooms. They're curled, coiled tightly into tiny hidden shapes, far too small for us to see. Like threads woven into the fibers of a tapestry, their influence is everywhere, even if their form is invisible. And how these extra dimensions are shaped, how they fold and twist and intersect, may determine the fundamental rules of a universe. In one configuration, they could give rise to particles that attract, creating a universe where gravity dominates. In another, they might cancel each other, creating a universe with no matter at all. Or perhaps they curve in just the right way to allow stars, chemistry, consciousness, a different twist, and none of it would exist. Change the geometry of a single hidden fold, and the universe that unfolds around it could be utterly alien, filled with new particles, new forces, new constants, and new kinds of life, or no life at all. These curled dimensions form what physicists call the landscape of string theory, and it is vast. Some estimates suggest there could be 10 circumflex, 500 different ways to shape these extra dimensions, each leading to a different version of physical reality. It's a number so large it eclipses imagination, a number greater than the total atoms in all the stars of all the galaxies in the observable universe. And if each version corresponds to a distinct universe, then the multiverse isn't just a poetic idea, it's a mathematical consequence. Each universe in this landscape is like a melody written in the language of geometry and vibration. Some are soft and slow, some chaotic and sharp, others utterly silent. Ours is one that happens to sing in the key of stars and carbon and water and minds, capable of asking questions like this. But we are only one note in the cosmic songbook. The dimensions that shape these universes are not flat or symmetrical. They are strange, knotted forms called Calabi-Yau manifolds, shapes that fold in on themselves in 6 dimensions, like origami crafted in a space we cannot picture. The mathematics needed to describe them is intricate and mysterious, filled with symmetries and dualities that seem to hint at deeper truths. In some versions of string theory, a universe with one set of properties is dual to another, with seemingly opposite ones. 2 realities that look different on the surface, but are reflections of the same deeper structure. It's almost as if the universe is trying to tell us something, that its complexity is not chaos, but a deeper kind of order, one we have only begun to glimpse. Still, for all its elegance, string theory is unproven. It offers no easy tests, no clear predictions that can be checked in a lab. The energy scales involved are far beyond anything we can reach. And yet, it continues to draw some of the sharpest minds in physics, not just because of its beauty, but because of its potential to unify everything, to merge gravity and quantum mechanics, space and time, particles and forces, into a single framework, a theory of everything. But if it is true, if the universe really rests on vibrating strings and hidden dimensions, then it changes our place in the cosmos. We are no longer lone observers in a single, privileged world. We are one outcome among many, one flower in a vast and unseen garden. Our laws of physics are not universal, they are local, shaped by the folds of invisible dimensions. Somewhere, perhaps, those folds bent differently, and another universe bloomed. In one, gravity may be weak, and light never bends. In another, the strong force never holds atoms together, and matter dissolves into dust. In yet another, time may flow backward, or space may loop in on itself like a Mobius strip. And in a few rare corners of this landscape, The tuning may be just right, permitting the slow alchemy of stars, the formation of planets, and the long unfolding of minds capable of curiosity. You, sitting here now, are a result of that tuning, not by chance, necessarily, but by presence. You can only find yourself in a universe that allows you to exist, and perhaps that's all the answer we ever get. String theory doesn't give us one universe. It gives us possibility. It paints a picture of reality, not as a singular truth, but as a spectrum of potential worlds, each governed by the way dimensions fold and strings hum. It invites us to see our cosmos not as the only one, but as one of many, an island in a sea of mathematical beauty. We may never travel to those other islands. We may never even know if they truly exist. But their possibility shifts the way we see our own world. It becomes not a given but a gift, a rare and fleeting arrangement in a much vaster whole. And somewhere, hidden in the folds of space, the strings continue to sing. Picture our universe not as a vast expanse, but as a surface, a kind of shimmering film, stretched out through space like a soap bubble floating quietly in an unseen breeze. Now imagine that this bubble isn't alone. It drifts through a higher dimensional realm we cannot sense, accompanied by other bubbles. Some may be close, others unimaginably far. Some may ripple in tandem with ours, while others remain entirely isolated, like dreams that never touch. This is the strange and beautiful idea of brains. In string theory, a brain short for membrane is a dimensional surface. Our universe, according to this theory, could be a three-dimensional brain embedded in a space of higher dimensions. Everything we know, from stars and galaxies to thoughts and touch and time itself, might be confined to this brain. We exist on its surface, like drawings inked onto a page. Light, matter, and all the forces of nature move along it. But beyond the page, beyond the edge of what we can see or measure, might lie the bulk and expanded, multidimensional space where other brains drift. And each one could be a universe, not just regions of our own cosmos, but entirely separate realms with their own stars, their own laws, their own timelines. Perhaps some are twisted and hot, crackling with different forms of matter. Others might be cold and still, with time slowed to a crawl. Some may contain life, minds, stories. Others may remain silent and empty, never lit by the spark of thought. If this is true, then the multiverse isn't an abstract idea. It's geography. Like continents separated by ocean, these universes might be real places, spread across a higher dimensional space, each a brain adrift in the cosmic sea. And just like tectonic plates shifting and grinding, these brains could collide. In one version of this theory, known as the ekpyrotic model, our universe may have begun not with a singular Big Bang, but with the impact of two brains. Like cymbals crashing together, their collision unleashed a shockwave of energy, an expanding firestorm that became the universe we now inhabit. Space and time, born not from a single point, but from the violent dance of higher dimensional surfaces. If brains can collide, they can also part, retreat, drift. And in the vast spaces between them, the rules may be different. Gravity might spill out into the bulk, stretching beyond our brain, while light remains trapped. This could explain why gravity is so much weaker than other forces, why a single magnet can lift a paperclip against the pull of the entire Earth. Perhaps gravity is diluted, leaking into the dimensions beyond, spreading like water through a sponge, while other forces remain anchored to the surface, the bulk. The higher dimensional realm in which all this unfolds is not empty. It's not a void, but a theater, and we are one scene among many. Our universe may be local, a chapter, a stanza, one rhythm in a much longer song. The other brains, the other bubbles, are out there too. We cannot touch them, not directly, not yet, but their existence might leave clues. Gravitational waves, rippling through the bulk, might pass from one brain to another. A collision in a neighboring universe might send tremors through the fabric of ours. The cosmic microwave background, the ancient light that fills our sky, might carry faint imprints of such distant encounters, scars left by brains brushing past each other long ago. Or perhaps these universes are forever separate, sealed away like pearls in a shell, each one a world complete unto itself. In some, the laws of physics might be just close enough to ours to produce familiar galaxies, even familiar minds. In others, the difference might be absolute, unrecognizable, but regardless of their contents, they would all be real. Not imagined, not hypothetical, real. It is tempting to think of our universe as the whole of everything, the totality of being, but string theory suggests otherwise. It offers a picture of reality not as a singular thread, but as a fabric woven from many strands, a cosmos stitched together from surfaces floating in higher realms. Each brain a world, each bubble a story, and perhaps, in some future yet to come, minds like ours or minds very different will find a way to peer across the bulk, to sense another brain, to know that we are not alone in the deeper architecture of reality. Or maybe, in a distant epoch, our universe will once again collide with another, sparking a new beginning, a new cycle. Creation born not from nothing, but from contact. In this view, the multiverse is not infinite variation layered atop itself, but physical worlds with shared ancestry, brains that move, stretch, bend, universes that breathe through their shape. And though the bulk remains hidden, though we are bound for now to our particular bubble, the possibility that others drift nearby changes the texture of our solitude. We are not the only page. We are part of a book with many leaves, and somewhere, perhaps only a dimension away, another world turns quietly in the dark. Before time as we know it began, before galaxies spun or atoms formed, there may have been movement, not a spark from nowhere, but a rhythm, an oscillation, a pulse that stretched across dimensions, not in noise, but in quiet pressure. In this view, the universe did not erupt from nothing. It arrived like a tide, pulled forward by a collision long foretold. Not a singular explosion, but a meeting of worlds. The ekpyrotic model imagines a cosmos built on cycles, like breath, like heartbeat, like seasons turning endlessly through time. Instead of a one-time Big Bang, it proposes that the universe is born, dies, and is born again not metaphorically, but physically, through the crashing together of colossal, higher-dimensional brains, each brain a universe in its own right, separated by an unseen gap in the higher-dimensional bulk, drifting slowly until they touch. And when they do, all of space and time erupts. The collision isn't violent in the way we imagine explosions. It's not chaotic fire and ruin. It's structured, predictable. The result of slow gravitational attraction between universes that were never entirely apart. And when they meet, when they finally touch, they unleash energy, heat, and motion. Space ignites into expansion, matter forms, and the cycle begins anew. Not from a point of nothingness, but from the meeting of something with something else. This view reshapes our origin story. In the traditional Big Bang, time has a beginning, a sharp edge, a moment when the universe springs from a singularity, an infinitesimal point of infinite density. But the ekpyrotic model softens that edge. Time doesn't begin, it flows. The moment of creation is not the start of everything, but a beat in a much longer song. And like all songs, it may have played before. Imagine this. Trillions of years from now, the universe as we know it has grown vast and cold. Stars have burned their fuel. Galaxies have thinned. Black holes have consumed what remains. The cosmos expands still, but quietly, like a sigh stretching into silence. It seems like an end, but according to this model, it is only the lead-in to a return. The brains begin to draw near once more. The slow gravitational drift pulls them closer, and in the distant dark, another collision looms. When they meet, another firestorm erupts. A new universe is born, not identical to ours, but connected. A continuation, not a replica. Each cycle reshapes the conditions for what comes next. Slight variations in density, in symmetry, in how the brains fold and ripple before they touch. Perhaps in one cycle, the universe is filled with vast structures and complex life. In another, it never cools enough for atoms to form. But the rhythm continues, unbroken. This model is named for the ancient Greek word ekpyrosis, meaning conflagration and all-consuming fire. In Stoic philosophy, the universe was thought to end in fire and be born again from its own ashes. It's a poetic idea, but here, it's not just metaphor. The ekpyrotic universe proposes that this cosmic burning is real, and that it happens again and again. It's difficult to grasp the scale. Each cycle might last trillions upon trillions of years, so long that the memory of the last would be erased entirely, except in the subtle fingerprints it leaves behind in the smoothness of space, the symmetry of physical laws, the temperature of ancient light. Perhaps even now, we are surrounded by clues, ghosts of previous universes, whispering their existence through the patterns in the cosmos. And yet, we feel no rumble from the brains. We see no wall approaching through the void. The process is too slow, too grand, for eyes like ours. But mathematically, it may resolve certain puzzles. Why the universe is so flat, so uniform. Why its energy is tuned just so. In traditional models, these facts require careful explanation, fine-tuning, inflation, coincidences, but in a cyclic cosmos, they arise naturally. Imperfections are smoothed out across eons. Each cycle resets, reshapes, refines. It also changes how we think about time. If the universe has no true beginning, then it also has no final end. It is not a story with a cover and a back. It is a circle, a wheel. Each existence leads to the next, not through reincarnation, but through physics. Time becomes a corridor with no start, only rooms, each one opening into another. We are living in one such room. There were others before us. There will be more after. Does that diminish the meaning of our moment, or does it deepen it? If we are one chapter in an eternal book, then our existence is not random, it is inevitable, a consequence of the universe doing what it always does, dying and beginning, crashing and blooming. In that sense, the story of our universe is not small, but part of something profoundly ancient. Our stars shine not for the first time, but as the latest expression of a pattern that has always been. And if this is true, then the cosmos is not fragile. It is resilient. It does not shatter. It renews. And in that renewal, in the slow dance of brains through the bulk, lies a kind of quiet comfort, that even in the deepest dark, beyond heat death, beyond collapse, there is not nothing but waiting, waiting for the next arrival, the next ignition. Somewhere beyond dimensions we can measure, our universe may already be preparing for its next beginning, its next breath. Imagine walking through a valley that stretches beyond sight in every direction. But this isn't a valley of grass and trees. It's a mathematical terrain, carved not by water or wind, but by equations. Every dip, every peak, every curve represents a different universe, its own rules, its own constants, its own laws of physics humming in a different key. This is the landscape of string theory, and it may be the most bewildering forest of possibilities the mind has ever tried to navigate. At the heart of string theory lies the idea that the fundamental particles of nature aren't tiny dots, but vibrating strings, infinitesimal filaments that twist and shimmer through dimensions too small to see. Their vibrations, like the pluck of a stringed instrument, determine the kind of particle they become. One note becomes an electron, another a photon, another perhaps something we've never glimpsed. But the strings don't vibrate in empty space. They vibrate in a space with structure, extra dimensions curled and folded in ways that shape the song. And here's where the universe begins to multiply. These hidden dimensions, the ones we don't see, can be curled in countless ways. Some might loop like a donut, others might twist like a Mobius strip. Each configuration changes the vibration of the strings, and with it, the forces of nature, the masses of particles, the strength of gravity, the very fabric of reality, not slightly, completely. In one configuration, stars form and galaxies swirl. In another, atoms can't hold together. In another still, time may behave so strangely that nothing like life could ever emerge. But string theory doesn't predict just a handful of such configurations. It allows for numbers so vast they strain the imagination. Not hundreds, not thousands, but numbers like 10 to the 500th power. That's a 1 followed by 500 zeros. More possible universes than there are atoms in our observable cosmos, each one a different version of reality, each one potentially as real as our own. This is the landscape problem. String theory, rather than pointing to one unique universe, the way we once hoped a theory of everything might points to an entire field of possibilities, and it offers no clear way to say why we live in this version and not another. Why our universe is expanding at just the right rate, why light travels the speed it does, why hydrogen forms, why stars burn steadily instead of flashing out or never lighting at all. At first, this seemed like a flaw, a bug in the system. Physics was supposed to explain why things are the way they are, not drown us in an endless menu of options. But over time, something strange happened. That overwhelming number of possibilities began to feel less like a glitch and more like a mirror, reflecting something we were already beginning to suspect, that our universe might not be alone. If all of these universes exist in some vast multiverse, if each valley on the landscape corresponds to a real, physical cosmos, then the mystery of why our universe seems so finely tuned might dissolve, not because we are special, but because we are one of the few places where complexity is possible, where observers can arise, where minds can ask questions. This idea is known as the anthropic principle. It doesn't say the universe was designed for us. It says we find ourselves in a universe where life is possible because, in all the others, there's no one around to notice. Most universes in the landscape may be sterile, empty, silent. But here, in this quiet corner of possibility, something stirred. And now we wonder, but even if this is true, even if the landscape is real, and these universes all exist, how could we ever know? Some scientists hope that tiny clues might remain, that the way our universe inflated in its first moments, or the way dark energy behaves, might point back to the shape of the dimensions underneath. That certain properties, like the existence of multiple families of particles, or the way certain forces unify, could offer hints about which valley we live in. But so far, the map remains blurred. We don't know which of the 10 circumflex 500 options is ours. We only know that this one works for now. And so, we're left in a strange position. We may live in a universe that isn't uniquely determined by first principles, but selected by a kind of cosmic lottery, not chosen, not willed, just found. A place that happens to work, floating in a sea of places that don't. Like a single island rising from an ocean of jagged stone, habitable only by the slimmest margin, that can feel dizzying or even lonely. But perhaps it's also beautiful, because in all that vastness, all that improbability, something found a way. Not because it had to, but because it could. We are the result not of inevitability, but of possibility. The landscape of string theory is not a place we can walk through, not yet, but it is a map of what might be, a reminder that even the deepest laws we hold dear, the strength of gravity, the mass of an electron, the ticking of time, may be local customs, not universal rules. That elsewhere, across invisible boundaries, Entire worlds may hum to different melodies, and though we may never visit them, their existence reshapes our sense of what is real. The universe is no longer a singular jewel. It is a gallery, a library, a landscape of dreams stacked beyond our horizon. And in one quiet corner of it, we opened our eyes and began to wonder why. There is something quietly comforting about circles. The way a season slips into the next, only to return again. The way tides rise and fall. The way your breath leaves and comes back. In the sky above, planets trace elliptical paths, cycling endlessly through space. And in some of the deepest theories of cosmology, time itself may not be a line, but a loop, an arc, a rhythm. A song played over and over, each time with new variations. Each universe not an isolated miracle, but a chapter in a story with no true beginning and no final end. Cyclic cosmology proposes that the universe is not a one-time burst into being, but a process that repeats. Birth, expansion, decay, collapse, then birth again. It's not just matter that is recycled. It's everything. Time, energy, the rules that govern reality itself. Everything is gathered up, reconfigured, and set in motion once more. This isn't the kind of recycling we do with bottles and paper. It's not even like the rebirth of stars from the ashes of older ones. This is recycling on a scale so vast it defies intuition. Entire universes, each with their own galaxies, histories, and lives, giving way to the next in an eternal chain. The idea is ancient, whispered by myth and echoed by modern mathematics. It's as if the universe breathes. Some versions of this model imagine a universe that expands until it stretches itself thin, like a drum skin pulled too tight. Gravity, once weak and fading, begins to gather strength. Galaxies drift apart, then slow. The momentum stalls, and then, ever so gently, the universe begins to contract. Light dims, heat fades, distances shrink. The stars collapse back into themselves. Matter gathers. The cosmos folds inward like a great tide retreating. Eventually, all that remains curls into an infinitesimal moment, a seed filled with memory, waiting for the next unfolding. And then silently it does. A new Big Bang, a new expansion, a new canvas. Perhaps the same physics, perhaps different, perhaps something barely recognizable, but always something. From the ashes of one universe, the embers of the next. This is not a one-time cosmic accident. It's a rhythm baked into the nature of time, a kind of heartbeat in the structure of existence. But not all cyclic models rely on a collapsing universe. Some, like conformal cyclic cosmology, suggest something stranger. They propose that as the universe expands forever, it loses track of scale. When everything is stretched so far apart and the last black holes have evaporated, there may be no more clocks to measure time, no more particles with mass. In a universe like that, size becomes meaningless. There's no way to tell if something is vast or minuscule. Everything is relative. And in that weird, ghostly state, the end of one universe may become indistinguishable from the beginning of another. Like fog rolling into fog, the end becomes the beginning. The final chapter curls gently into the first. It's difficult to imagine. We think of time as an arrow, a path that begins at the Big Bang and moves forward, always forward. But perhaps it's more like a wheel, turning quietly behind the curtain of existence. And we, our stars, our questions, our music, are all part of one spin of the cycle. There may have been others before. Universes that collapsed into silence. Universes that ended in endless expansion. Universes that folded into themselves in ways we cannot yet trace. Their fingerprints may be faint, but perhaps still there in the shape of the cosmic microwave background, in the smoothness of space-time, in the whispered anomalies we haven't yet learned how to read. And if there will be more universes after ours, then we are not living at the center of anything. We are not the start of the story, nor its close. We are a middle movement in an eternal symphony, a melody played once in our key, before changing into something new. This idea reshapes the very concept of eternity, not a cold, static forever, but a living, breathing infinity, a universe that renews itself, like a forest regrowing after fire or a mind waking from sleep. In one version of the cycle, there may have been a universe before ours that held its own civilizations, its own questions, perhaps even their own science, looking up into their skies and wondering where it all began. They may have suspected, as we do, that they were part of something bigger. They may have guessed, as we now do, that their time would not be the end. We don't know what echoes from their existence might remain. A particle here, a tiny wrinkle in space-time. But if the cycle continues, we may someday leave whispers for those who come next. Not messages in bottles, but imprints in the cosmic sea. Patterns, numbers, shadows of stars long gone. Proof that something lived here, once, and wondered why. There's something deeply peaceful about that. About the idea that nothing is ever truly lost. That the universe never wastes anything. It changes. It transforms. But it does not forget. Not entirely. Every atom in your body was forged in a star that lived and died before Earth even formed. And perhaps those stars were themselves shaped by cycles before them. Not just the cycles of stellar life and death, but the greater cosmic rhythm behind them all. A rhythm that never ends. A rhythm that includes us. In the quiet of space, between the galaxies, beyond the light of any star, time may be looping. Not cruelly, not endlessly, but meaningfully. Cycles of possibility, each one unique, each one inevitable. A cosmic recycling, not of trash, but of wonder. And in this loop, we are both a consequence and a beginning, a spark lit by the last flame and fuel for the next. The multiverse may be one of the most staggering ideas ever proposed in science, and yet it is constantly haunted by a quiet, persistent question. Is it science at all? We're taught that science is built on experiments, on observation, on testable predictions that can be confirmed or denied by nature itself. Drop a stone, measure its fall, peer through a telescope, watch a planet move, run an equation, then let the universe reply. That's the contract. We guess, and the cosmos tells us if we're right. But the multiverse offers no such easy conversation. By its very nature, it describes realms we cannot see, worlds beyond our cosmic horizon, versions of reality forever out of reach, parallel lives that branch with each decision but never touch. It gestures to infinities and hypotheticals. It suggests that our universe may be just one thread in a vast tapestry, but we can only ever feel the thread we're on. So, where does that leave us? Is the multiverse a scientific theory, or a philosophical one wrapped in the language of physics? To answer that, we must first understand what science really is and where its edges blur. Science is not just a list of facts. It's a method, a way of testing our guesses against the world. But not all scientific ideas are immediately testable. Some begin as frameworks, lenses through which we try to make sense of what we see. Germ theory was once unprovable, merely a pattern observed. Evolution, too, began as an idea drawn from fossils and variation long before genes were mapped. In that light, the multiverse may be in its early days not yet confirmed, but potentially confirmable. Or at least, that's the hope. Some versions of the multiverse do lead to testable consequences, at least in principle. Eternal inflation predicts that our universe is just one bubble in an ever-growing foam, and while we can't see the others, collisions between bubbles might leave scars, circular imprints in the cosmic microwave background, for example. Quantum multiverses arise from equations we already use to build technology. Their logic is embedded in the fabric of our most accurate physical theories, even if their interpretations remain debated. Simulated universes might be detectable if we can spot anomalies in physical constants like pixelation in the laws of nature. But these are subtle clues, not smoking guns, and many physicists are cautious. The danger lies in untethering our ideas from evidence. If anything imaginable becomes real just because it solves a problem or feels elegant, then we risk leaving science behind and drifting into metaphysics. Theories must earn their place by risk, by exposing themselves to falsification. Without that, they may become castles in the sky, beautiful perhaps, but unreachable, untouchable, and ultimately unfalsifiable. Yet at the same time, imagination is essential. Every great scientific leap began with a moment of conceptual daring. Newton imagined invisible forces connecting objects across space. Einstein reimagined time as a pliable thing. Schrödinger dreamed of cats both dead and alive. At the bleeding edge of understanding, the line between science and philosophy has always been thin. The multiverse walks that line. It offers solutions to deep puzzles: why our universe seems fine-tuned for life, why quantum events appear random, why inflation appears to have occurred, and it packages these solutions in stories that extend beyond our reach. It stretches the scope of our thinking, invites us to reimagine what universe even means. And yet, some worry that it asks us to believe too much without enough grounding. But belief is not the goal. Understanding is. The multiverse may not be a theory in itself, but a consequence, a prediction that arises naturally from other theories we do trust. If inflation is correct, and quantum mechanics is accurate, and string theory describes reality's hidden layers, then a multiverse is not a fantasy, it's a logical outcome. To reject it, we would have to reject the foundations it's built upon. Still, it's strange. To speak of other universes we cannot touch feels like a betrayal of science's core humility, its insistence on knowing only what can be known. But there's another humility at play here too, the recognition that the universe is under no obligation to be simple or small or comfortably observable. It may well be larger than our methods can currently reach. And if that's true, then the job of science is not to deny it, but to keep growing until it can. Some physicists draw a line. They argue that unless a multiverse prediction leads to unique, testable consequences in our own universe, it's not physics. Others argue for a broader view, one that includes theory, confirmation through indirect evidence, through coherence with what we already know, through explanatory power. It's not an easy debate, and maybe it shouldn't be, because the frontier of knowledge is never tidy. It is messy, tangled, filled with overlapping stories and shifting interpretations. The history of science is a history of ideas that once seemed wild atoms, curved space, deep time becoming not only accepted but foundational. The multiverse may one day join them, or it may fade, replaced by deeper truths we haven't yet imagined. But today, it remains a liminal idea, too scientific for pure philosophy, too philosophical for pure science, a shimmering possibility at the edge of reason, held in place by equations we trust and doubts we must honor. And perhaps that's where it belongs for now, on the boundary between what we know and what we are still learning to believe. Not as dogma, not as certainty, but as invitation. An invitation to think larger, to wonder further, to keep looking into the dark and asking what if. Long before telescopes mapped galaxies or equations whispered of parallel realms, humans looked up at the night sky and imagined more than one world. They didn't need particle accelerators or inflation models to wonder if this universe was alone. Their stories told around fires, etched into stone, sung to the rhythm of wind and drum, carried multiverses of their own. Not theories, not data, but visions, symbols, echoes of a truth too vast to name directly. In the ancient texts of Hindu cosmology, the idea of many worlds was not speculative, it was foundational. The universe was not created once, but in cycles, endlessly born, lived, and destroyed, only to rise again. Time itself was immense, measured not in years but in kalpas, cosmic epochs that stretch for billions of years. Each kalpa brought a new creation, a new reality, with gods and beings specific to its moment in the cycle. This was not metaphor. It was a worldview in which our universe was one bubble in an infinite sea of time and space, ever renewing, ever transforming. Within these traditions, there wasn't just one cosmos, but countless lokas, planes of existence stacked like invisible layers of reality. Some were realms of gods, others of demons, some peaceful, some chaotic, each vibrating at its own frequency of karma and form. The idea that we lived in just one plane was seen as a limitation of perception, not of truth. Reality was a multi-layered thing, glimpsed only in pieces. Far north, among the icy branches of Norse mythology, the cosmos was also imagined as plural. Yggdrasil, the world tree, held together 9 realms, each a universe unto itself. Midgard was our world, the realm of humans, surrounded by others. Asgard for the gods, Jotunheim for the giants, Niflheim for the dead. These were not merely poetic metaphors, but deeply believed structures of being. The gods crossed realms, time looped and knotted, and fate, always fate, wove its threads through them all. Across the ocean, indigenous Australian Dreamtime stories offered another kind of multiverse, one not of space, but of time, layered upon time. In the dreaming, all things exist simultaneously in mythic and physical dimensions. Ancestors walked the land and shaped it, and their actions continue to echo through the present. Every rock, every stream, every breath of wind is a portal, a reminder that reality has depth, that the now is never only now. The world is constantly being dreamed into existence by those who came before and those yet to come. The Mayans spoke of previous worlds destroyed by flood, fire, or darkness, each replaced by another, each a refinement, or a lesson, or a necessary collapse. The Aztecs told of 5 suns, 5 creations, each overseen by a different god, each doomed in turn. In their vision, we live under the 5th sun, the current world, always one heartbeat away from the next great shift. Among the Diné people of the American Southwest, emergent stories tell of ancestors rising through layered worlds, from the dark, watery first to the bright, complex world we now inhabit. Each previous world was real, inhabited, transformed. Each collapse was not an ending, but a passage. And in Buddhist cosmology, universes are not merely recycled, but mirrored. The Buddha is said to have taught in countless world systems, each with its own beings, each capable of awakening. Reality is a vast garden, blooming in infinite forms, each petal a possible world. And even enlightenment is not fixed. It unfolds in layers across space and mind. It's easy, in our age of data and instruments, to dismiss these stories as quaint or archaic. But they are more than myth. They are maps not of physical terrain, but of human understanding. They reflect a pattern in the psyche, a deep intuition that reality is not singular, that existence is more like a prism than a line. These stories survived not because they were proven, but because they resonated. They felt true, in the bones, in the breath, in the silence between words. What's striking is how many of these ancient visions rhyme with modern theory, not in detail, of course not in equations or predictions, but in mood, in possibility, in the idea that what we see is not all there is, that behind the curtain of perception lies a theater of countless acts, each unfolding in its own time, in its own way, that our universe might be one of many, not just in space, but in experience. Perhaps science and myth are not opposites, but companions. Science tells us what's measurable. Myth tells us what matters. One defines, the other reveals. One dissects the stars, the other makes us feel them. And in the quiet spaces where they meet in stories of brains and bouncing worlds, in songs of world trees and dreamings, we find ourselves not at the end of understanding, but at its beginning. We are pattern-seeking beings in a pattern-filled universe, and whether those patterns come wrapped in numbers or in story, they point to the same mystery, that existence is richer, stranger, and more beautiful than we ever expected, and that maybe, just maybe, we've been imagining the multiverse far longer than we've been trying to prove it. Infinity is a word we learn early and never truly understand. As children, it sounds like magic, a number that never ends, a staircase with no final step. You might remember first hearing it on a playground, in a tug-of-war of times a million, times a billion, times infinity, followed by the inevitable coup, infinity plus one. That phrase, so small and so bold, manages to break something open. It hints at a truth that even grown-ups struggle with, that infinity, real infinity, is not a number. It's not even a place. It's a boundary where our intuition begins to fray. In cosmology, infinity creeps in like a quiet tide. At first, it's a convenience, a way to simplify equations, to describe an expanding universe without fussing about edges. But then, like a fractal, it begins to reveal its depth. If space is infinite, it contains not just galaxies beyond counting, but every possible arrangement of matter, not just once, but again and again and again somewhere far enough away, a region of space could exist that's indistinguishable from our own. Further still, one with you in it. And further still, one where you chose something else, said something else, lived something else. This isn't metaphor, it's math. The observable universe, what we can see, is enormous but finite. Light, after all, has a speed limit, and the universe has an age. So we live in a bubble, about 93 billion light-years across, filled with stars and dust and ancient light from the Big Bang. But beyond that, no one knows. The equations suggest that space might go on forever, not figuratively, literally, forever. And if space is infinite, and if matter is distributed more or less evenly, then the implications become bizarre. In an infinite universe, every random arrangement of particles will occur somewhere, not just once, but an infinite number of times. That means there are infinite Earths, infinite histories, infinite yous, some of them nearly identical, some unimaginably different. Here's where the trouble begins. Infinity isn't just big, it's unmanageable. Our tools, logic, probability, intuition falter when applied to endlessness. In a finite universe, we can talk about chances, the odds of something happening, the frequency of certain events. But in an infinite one, everything that can happen does happen, somewhere. So what does it even mean to ask if something is likely? If every outcome occurs an infinite number of times, how do you count them? How do you define typical or rare when every outcome is both infinitely common and infinitely buried? This problem has a name, the measure problem. It plagues cosmologists who try to make predictions in models that include infinities, because to do that, you need a way to compare infinities to weigh them, somehow, against each other. But that's slippery ground. Choose one method of measuring, and you might conclude that universes like ours are common. Choose another, and suddenly they're vanishingly rare. The math can shift reality beneath your feet, like a landscape drawn in sand. Even worse, infinities invite paradox. If you accept that there are infinite observers like you, scattered across the cosmos, then the very fact that you find yourself here in a life that seems coherent, on a planet that seems stable, becomes problematic. Why not in a more chaotic version? Why not as a brain that blinked into existence, surrounded by illusion? This is the heart of the Boltzmann brain problem, which we explored earlier, a warning sign that infinity, when left untamed, can lead to absurdity. In science, infinities often signal a flaw in the theory. When equations spit out infinite values like infinite density at the center of a black hole, or infinite temperature at the start of the Big Bang, it's usually a hint that something is incomplete, that we're missing a deeper truth, a new framework that smooths out the singularity and tames the endless. But in cosmology, infinity is harder to escape. It may be baked into the structure of the universe itself, and it doesn't stop with space. Time, too, might be infinite. The future could stretch on forever, which raises another unsettling thought. If the universe lasts forever, then the number of events it contains is also infinite, and over enough time, even the most unlikely events become inevitable. Particles dance into place, galaxies reassemble, whole histories recur. In such a future, entropy the gradual, spreading out of energy marches on. Stars burn out, black holes evaporate. The universe grows cold, dark, and still. But given infinite time, even that quiet might crack. Random fluctuations could create new universes, new big bangs, new cycles. Some theories embrace this. They see the cosmos as a kind of eternal engine, where existence never truly ends, only shifts shape. Others suggest that infinity is an illusion, a useful fiction, that perhaps space isn't truly infinite, just very large, that perhaps the apparent endlessness is a trick of perspective, like looking into parallel mirrors and seeing yourself repeated without end. Still, the idea remains. Haunting, beautiful, unsettling, infinity forces us to confront the limits of comprehension. It reveals how much of our reasoning depends on finiteness, on counting, comparing, bounding things. Without those limits, meaning itself begins to dissolve. Every story is told. Every version is lived. Every question is answered yes, and also no, and also something in between. And yet, infinity also humbles. It reminds us that the universe does not owe us simplicity, that our minds, evolved to navigate forests and families and food, may be ill-equipped to grasp the full architecture of reality. Maybe that's why, for all its strangeness, infinity remains so compelling. It's not just a feature of equations or theories, it's an invitation, a call to expand our thinking, to stretch imagination until it aches, to wonder not just what is, but what could be, and what must be, if infinity is real. Some theories whisper that our universe may not be the only one that exists, not just in space, but in history, not just spread outward like stars scattered through infinite night, but stretched backward, like roots reaching into epochs before time as we know it began. And within that whisper lies an idea stranger still, that universes might evolve, that beyond all our telescopes and equations, there could be something like a natural selection of worlds, a quiet, patient winnowing across the multiverse, where certain kinds of universes reproduce and others do not. It's a theory known as cosmological natural selection, or sometimes, more poetically, cosmological Darwinism, proposed by physicist Lee Smolin in the 1990 seconds. It begins with a simple but radical question. Could our universe be the product of a kind of cosmic fertility? Not designed, not chosen, but selected over and over again across incomprehensible time. The idea turns the concept of multiverse into something not just vast, but alive with process. In Smolin's view, universes may spawn new universes, not randomly or rarely, but through the very physics that govern their deaths. Black holes, those mysterious abysses where space and time buckle into singularities, might not just destroy, they might create. According to the theory, each black hole could be a kind of cosmic womb, birthing a new universe on the other side of its collapse, sealed off from its parent like a soap bubble drifting free from the wand. And if that's true, then each new universe inherits some traits from the one before. Not in the way a child inherits freckles or the curl of a smile, but in terms of physical constants, the values that define the character of a cosmos, the strength of gravity, the masses of particles, the balance between fundamental forces. These constants shape everything, whether stars form, whether matter clumps, whether chemistry becomes possible. Most combinations produce barren, sterile spaces, but some rare and precise give rise to structure, to life, to thought, and crucially, some give rise to black holes. In this view, universes that happen to produce more black holes will, in turn, produce more offspring, and over time, the multiverse becomes filled with descendants of universes fine-tuned for black hole production. Not because of design, not because of purpose, but because of a blind, recursive process, trial and error written across the fabric of existence. That's where the idea begins to shimmer with implication. Because if our universe is one of these prolific black hole makers, then we would expect it to have the kinds of laws and constants that encourage structure, gravity balanced just so. Stars that live long enough to forge elements, space that expands, but not too fast, chemistry complex enough to support the slow unfolding of complexity. Life, in this theory, is not the goal, but a side effect, a byproduct of conditions that favor the universe's own reproduction. It's a bold idea, elegant in some ways, unsettling in others, because it suggests that our universe is not the best in any moral or aesthetic sense. It's not the most beautiful or the most benevolent. It's simply the one that works, the one that survives, the one that, by sheer accident of physics, happened to spawn generation after generation of similar worlds. Of course, this theory, like so many that tread into the multiverse, is difficult to test. We cannot peer into a black hole and see what lies beyond. We cannot observe daughter universes branching off in silence. But the theory does make predictions. It suggests that the constants of nature should be close to local maxima for black hole production. Change them slightly, and fewer black holes should result. And while we can't measure other universes, we can run simulations. We can tweak our universe on paper and see what happens. Smolin's proposal exists on the edge between physics and philosophy, like so many of the ideas we've explored. It doesn't claim to answer every question. It doesn't explain why universes exist at all, or why the process of selection works the way it does. But it offers a way to think about fine-tuning without invoking design or coincidence. A third path, between divinity and chance. Other thinkers have proposed similar ideas. Some imagine a meta-evolution, where laws themselves evolve through unknown processes. Others see information as the ultimate substrate universes emerging like patterns in a great computational sea. These models differ in detail, but they share a spirit, the idea that reality may have layers, that the laws we take as given might themselves be shaped by deeper, more subtle forces. Still, the question lingers like mist at the edge of dawn. Is this the best possible universe? We feel tempted to say yes, to believe that we live in a world specially made for life, for love, for music and dreams. But best is a slippery word. In physics, there is no metric for meaning, no formula for fulfillment. A universe can be rich in stars or rich in silence. It can teem with life or rest in endless stillness. Best depends on the eye that sees, and perhaps on whether any eye exists at all. What cosmological natural selection offers is a way to shift the question. Not why is our universe perfect, but what processes gave rise to the kind of universe where stars can live and die. It's a reframing, a soft turning of the kaleidoscope. It suggests that the cosmos, vast and indifferent, might still follow patterns that resemble the rhythms of life, and in doing so, it whispers something quietly profound, that maybe we are not the center of the story, but maybe we are not separate from it either. Maybe we are one thread in a much older tapestry, woven from laws and chance and replication across aeons. Maybe our thoughts, our cities, our stories, are echoes of a process deeper than we can yet imagine. Not the reason the universe exists, but a reflection of how it endures. Not the goal, but the consequence. Imagine, for a moment, that every choice you've ever made, and every choice you could have made still echoes somewhere. That each fork in the road did not simply vanish into memory, but instead gave rise to a new world, spinning quietly alongside this one. In one, you turned away. In another, you stayed. In one, you said the thing you regretted. In another, you found the words just in time. Each decision, large or small, branching off like a tendril of lightning through the fabric of the cosmos, tracing every possibility into being. It's a beautiful idea, and a terrifying one, because if every version of you exists, in some form, in some distant quantum flicker, then what, exactly, do our choices mean? In the many worlds interpretation of quantum mechanics, the universe does not collapse to a single outcome when faced with uncertainty. Instead, it splits effortlessly, silently, allowing all outcomes to occur. When you flip a coin, the universe does not choose heads or tails. It embraces both. In one strand of reality, the coin lands heads up, and in another, tails. The same for every gamble, every whispered confession, every moment when you could have gone left, but went right. The universe, it seems, is unwilling to discard even a single path, and so it keeps them all. This raises an uneasy question. If every version of you already exists, if, somewhere, there is a version of you who made the right decision, and another who made the wrong, does that relieve you of responsibility? Does it mean that morality, that effort, that integrity are illusions? If somewhere there is a version of you who never hurt anyone, who always spoke with kindness, who lived bravely and never ran, is that good enough? Or does that very thought let us off the hook? This is where the many worlds theory brushes up against something deeply human. Not physics, but ethics. Not probability, but purpose. Because while the mathematics may be content with infinite U's, our hearts are not so easily divided. We live here, now. Our pain is local. Our regrets are real. And even if another version of you went back to say sorry, it does not erase the silence you left behind in this one. In a universe without branches, choices are heavy with consequence. They shape the only path we walk. But in a branching universe, choices still shape the path, just not all of them. They shape this one, the one you inhabit, the one you feel in your chest when you're lying awake at night, wondering if you did the right thing. And so, the moral weight of a choice doesn't disappear in the multiverse. It simply localizes. It becomes less about ultimate outcomes and more about presence, about integrity, about who you are in the world you're in. If infinite versions of you exist, perhaps the question shifts from which one is right to which one are you choosing to be. This reframes morality not as a rule book, but as a mirror. It isn't about cosmic accounting. It's about coherence, not in the quantum sense, but in the personal one. Do your actions align with the kind of person you believe yourself to be? Do they harmonize with your inner world, even if the outer world splinters in every direction? In some ways, this view is oddly comforting. It allows for compassion, for understanding. The version of you who made a mistake is not all of you. The version of someone who hurt you is not all of them. There are perhaps versions who tried harder, who were gentler, who simply had more time. Knowing this doesn't absolve anyone of harm, but it invites a kind of grace, a quiet acknowledgement that identity is not a single thread, but a tapestry, that we are not bound by our worst moments, nor defined by our best. And still, we must choose. That's the paradox. The infinite doesn't free us from morality. It deepens it. Because in a sea of endless versions, the one you're living becomes precious. It becomes real, not in contrast to the others, but in spite of them. You are not responsible for the universe. You are responsible for your corner of it. The hands you hold, the words you speak, the path your feet press into the ground. And if every universe is a branching story, then perhaps morality is the tone of your chapter, the way your presence echoes into the lives around you, especially if those echoes fade quickly. Perhaps meaning doesn't arise from being singular, but from being sincere. There is a quiet dignity in that. And maybe, just maybe, the other versions of you, the ones that never had the courage, or the ones that fell a little too far, maybe they're counting on this one to get it right. Maybe the version of you reading this right now is not alone, but part of a constellation. And maybe your choices send ripples not through space, but through soul. In a branching universe, morality is not diminished. It is distilled. There is something strangely calming about the limits of our knowing. The idea that, even after all the telescopes, all the equations etched in chalk across midnight blackboards, all the particles split and reassembled in cyclotrons beneath the Earth, we still do not know how many universes there are. We don't even know, with certainty, if there are others at all. And yet, the question persists, not just as a scientific puzzle, but as a kind of yearning, as if we're not simply asking about physics, but about ourselves, as if we are reaching for the edge of the mirror, trying to see what lies behind our reflection. How many multiverses are there? It's the sort of question that can't help but expand as you sit with it. It unfolds like origami in reverse simple on the surface, but opening into layers, into paradoxes, into infinities that can't quite be held in the hand. Because it isn't just a matter of counting. To count them would imply they can be contained. It would mean there is a boundary, even if it stretches beyond comprehension. But the multiverse, if it exists, might not be a number at all. It might be a sea, a process, a blooming. Some versions of the idea suggest there are just a few, perhaps 10, perhaps 100. Others gesture toward impossibly large numbers, 10 raised to the power of 500, universes scattered like seeds across the soil of possibility. And still others whisper of true infinity, of branching paths that never stop splitting, of fields inflating eternally, of string landscapes sprawling in every direction, wrapped in dimensions will never unfold. In these models, there is no how many, only how deep. And yet, even amid this vastness, we remain here grounded in one world. One reality with blue skies and birdsong and fingerprints on coffee cups. The moment you are in now is one out of uncountable possibilities, and still, it is everything. You breathe in a single atmosphere. You walk through one unfolding present. You carry one beating heart, full of questions it will never answer completely. And maybe that's the point. To wonder about the multiverse is not just to wonder what is out there, it's to wonder what this is, here. If there are other universes, then this one is not all there is, and that could be dizzying. But it could also be beautiful, because then, every moment you live is one strand in an infinite tapestry, and if there are no other universes, if this is it, then the fact that this one exists at all becomes a kind of miracle. Either way, the awe remains. Science pushes the boundaries of what can be tested. It maps what can be seen, measured, repeated. But the multiverse sits right at the edge of that map, blurring into something else. Some physicists treat it as a serious hypothesis, drawn from the logic of equations we trust. Others see it as metaphysical frosting, interesting but unprovable. Still, the idea refuses to leave. It keeps returning in different forms, like a melody echoing through different instruments, in inflationary theory, in quantum mechanics, in string theory, in myth. Because maybe it was never just a scientific idea. Maybe it's something older. Humans have always imagined other worlds, other heavens, other versions of ourselves. Not because we're trying to escape, but because we're trying to understand. To understand why this life feels so fragile and vast at the same time. Why there is so much joy and so much loss. Why the stars are so far away, and why, despite that, they feel so close. Perhaps the multiverse is not only a theory, but a mirror held up to our deepest longing, the hope that our story is not the only one being told. that existence is not a single thread that can be cut, but a weave, a braid, a song with many harmonies, only one of which we can hear. And that's what makes it all so tender, the not knowing, the not touching, the sheer wonder of imagining what might be. How many multiverses are there? We don't know. We may never know, but we can wonder. And sometimes wonder is enough. It is not passive. It is not idle. It is an act of courage to gaze into the darkness and imagine more light. To accept that the universe may be stranger than we can grasp, and to love it anyway. To wake each day in this one version of reality and still reach, gently, toward the rest. Maybe, in the end, that's what makes us human. Not just our ability to ask, but our ability to ask beautifully,